Math 1314, Tyler Junior College, Section 6.5, Cramer's Rule. Video 4, using Cramer's Rule to solve a 2x2 system. In the previous video, we came up with all Cramer's Rule, and we wrote it generically and had a bunch of letters, and it kind of looked like a big mess. But I really think Cramer's Rule is easier to explain when it's in action with a specific problem. And as we go through this, I'll remind you what the components of Cramer's Rule were in terms of finding the numerators and denominators of the ratios that give the solution to the system. In this example, we're going to solve 3x plus 2y equals 19 and 2x minus 7y equals 24. Now, I'm fully aware we can solve this a variety of ways. We can solve it using substitution. We could graph both of them and hope they intersect at a nice point, or we could solve it using addition. But the nice thing about Cramer's rule is there's no setup aside from the fact that everything is lined up. X is on top of X's, Y on top of Y's, and constants on top of constants, and equals on top of equals. But assuming that your system is set up, you can instantly start writing the answer. How? Here's how. Let's take this thickness down a notch. Start by setting up both fractions. And we're going to start with their denominators. You know what? I think I'm going to write the y somewhere else. So give me a second to erase this, and I'll put the y next to it. And then we'll evaluate both of these determinants in the space below. What is going on here? So we're going to set up all of our determinants. And let me make those lines a little bit further apart. I want to make sure I leave myself plenty of room to do this. There we go. I don't want to go too far down because I want to make sure I have room below to write what's going to happen at the end. All right, so we're setting up one determinant on top of another for both of these values, x and y. All right, you start by looking at the 2x2 determinant of the coefficient. So you just look here, ignore the letters, and write down what you see. That will be both of your denominators. So our matrix in the denominators will be 3, 2, 2, negative 7. 3, 2, 2, negative 7. And we really only have to evaluate it once because it'll be the same value in both of them. So that part's pretty easy. The denominator is just the determinant of the coefficients, the coefficient matrix, if you will. Now, as far as the x's and the y's, here's what I like to think. When I'm doing the numerator for the x, I'm going to replace the x coefficients, but not the y's. So I'm going to bring up the same y coefficients as before. The constant terms are going to take the place of the coefficients of the x. So in other words, I'm going to put 19 and 24 where the 3 and the 2 used to be. And for the y, I'm going to do the same thing. The only difference is when I do the y, I'm replacing the y coefficients and the x ones are staying the same. So for the y, come back. For the y, I'm going to take the constants. What's going on here? Hold on, folks. For the y, I'm going to take the constants and use them to replace the y coordinates, coefficients. So instead of 2, negative 7 in the y column, I'm going to have 13 and 24. Make sure you see what happened here because this is the critical juncture for setting up Cramer's rule. The denominators of both fractions is just the determinant of the matrix of the coefficients. In other words, grab the numbers from the x and the y, throw out the x and the y, look at that 2x2 array of numbers, and that's your determinant for both denominators. But for the numerators, and listen very closely, on the x, you replace the x coefficients, and on the y, you replace the y coefficients. On the x, you replace the x coefficients, and on the y, you replace the y coefficients. So if you can get it set up, then you're practically home free. And I'm going to type these down here because it'll be a little bit cleaner and possibly have enough room. So for example, actually, this is a fraction, so I'm going to draw it. You know what? I'm going to move both of these ratios of determinants to the next page. But in order not to waste your time, I am going to pause the video and then set up the next page. All right. I've got the next page set up. Just to make sure I got it set up correctly. Going back and forth between the two, just looking to make sure everything copied over correctly. Looks like it did. All right, now comes the evaluation part. All we have to do is find the correct products and subtract them. And I'm going to use a little bit of the same color that I used in the previous videos. I'm going to multiply the main diagonals in yellow. So let's go ahead and get all those set up. On the top, we have 19 times -7, which is a fairly large number. I'm not going to waste our time doing it in my head. It wouldn't take very long, but 19 times 7 is 133. So 19 times -7 is -133. On the bottom of the x, we have 3 times -7, which is -21. And let me go ahead and set up the y's also. Okay. On the top of the y, we have 3 times 24, which is 72. And on the bottom of the y, we have 3 times -7, which is -21. Now, normally I wouldn't do all four of those products at once. I'd do the first determinant, the second determinant, third determinant, fourth determinant. But I'm just doing this to remind you of how we start determinants. We start by multiplying on the main diagonal. Then we multiply along the other diagonals. We multiply along the other diagonals. And when we do that, in the numerator of the x, we have 24 times 2, which is 48. In the denominator, we have 2 times 2, which is 4. In the numerator of the y, we have 2 times 19, which is 38. And in the denominator of the y, we have 2 times 2, which is 4. I'm getting a little bit concerned because these answers are supposed to come out pretty. And in all of them, we subtract. So let's see what that gives us. The denominators are both -25. Full disclosure, when I set up this problem, I set it up to have nice answers, and it doesn't look like it's going to happen. In the numerator of the x, we have -133 and -48, which is -181. Okay, this isn't doing what I was supposed to do. I messed up something. And in the numerator of the y, 72 minus 38 is 34. What was supposed to happen is that these are supposed to reduce to 5 and -2. I clearly set up something incorrectly. I'll pause the video and go back and find out what it was in a moment. But as far as solving a system, you set up, I can't help but to look right now. I'll figure it out in a minute. You set up the determinants in the denominator, which is just the matrix of coefficients. And in the numerators, for the x numerator, you replace the x with the constants. And for the y numerator, you replace the y's with the constants. And then you just evaluate all the determinants and get to a point where you try to simplify the answer as much as possible. Neither fraction reduces, but the first fraction, the x, does come out positive. So my answer to this would be 181/25. And we'll pull the negative out of the second one, make it -34/25. Okay, I got to pause this video and figure out what happened. The solution to this was supposed to be 5, -2. I'm going to figure out what went wrong, be right back, and explain to you why I thought it was supposed to be a certain way, just to get you inside of my head. All right, to figure out the mistake that I made. When a professor or a teacher makes up a system to solve, what they usually do is have the solution in mind. Like, I want x to be 5 and y to be -2. And then they write the left sides of the equation, plug in the solution to figure out what the right side should be. So when I set this up, like on the bottom, I was thinking 2 times 5 is 10. 7 times -2 is -14. 10 minus -14 is +24. Problem is, I didn't do the math correct up here. 3 times 5 is 15. 2 times -2 is -4. 15 plus -4 is 11. What I did was 15 plus 4 and got 19. So this 19 was supposed to be an 11. So we're going to change the system just a little bit. We're going to replace the 19 with 11, and we're going to solve it again. And this time I want to show you how efficiently this should be able to go. Give me 1 second to get it set up. All right, so just consider this a second example. All I did is change the 19 to an 11 because this is what it was supposed to be. I want to show you one that comes out clean. All right, so we start by setting up our matrices, our determinants. I like to start with the denominators because the determinant in the denominator is literally just the coefficients of the x's and the y's. So in the denominator, my determinant will be 3, 2, 2, negative 7, which should come out the same as before. And this is where most people get lost with Cramer's rule, but it's not that hard to do if you listen very closely. For the numerator, we're going to set up the same matrix, except we're going to replace the x for the x's, replace the y for the y's. So in the x numerator, I'm going to replace the x's but keep the y the same. And I'm going to replace the x's with the x coefficients, I should say, with the constant terms on the right side of the equal sign, 11 and 24. And for the y's, I'm going to do the same thing. I'm going to replace the y's with 11 and 24, but I'm going to keep the x's the same, so 3 and 2. All right. Now I'm going to work these like I would normally work them. Back here, we did all the yellow products first and all the pink products second. I'm not going to be switching back and actually, I will switch back and forth between yellow and pink just because I want to be consistent. All right, starting with the numerator of the x. 11 times negative 7 is negative 77. And then the other diagonal product, 2 times 24, that's 48. And then to do the determinant, we subtract. In the denominator, we already know how that's going to turn out, but we'll do it again. We have 3 times negative 7, which is negative 21. And in the other diagonal, we have, in the other diagonal, we have 2 times 2, which of course is 4. And part of the definition of the 2 by 2 determinant is to subtract those results. Now, we already know the denominators are going to be the same, so let's go ahead and put a negative 21 minus 4 in the denominator of the y. And for the numerator of the y, our main diagonal product is 3 times 24, which is 72. Our off diagonal product is 2 times 11. 2 times 11, which of course is 22. And then the definition of the 2 by 2 determinant says to subtract those. And now this is going to play out how it was supposed to. We get x equals negative 77 minus 48 is negative 125. In the denominator, we get negative 21 minus 24, which is negative 25. First off, negative divided by negative is positive, and secondly, 125 divided by 25 is 5. And on the y, in the numerator, 72 minus 22 is 50. The denominator is still negative 25. 50 divided by negative 25 is negative 2. So our solution is 5 comma negative 2, or at least our solution is an ordered pair. It takes a little while to get used to setting up Cramer's rule, but once you understand how easily it sets up, determinant of the coefficients in the denominators, and for the numerators, on the x, we replace the x's with the constants, and on the y, we replace the y's with the constants, and then we just evaluate everything and then take it down a notch. In the last video for this series, we're going to explain why it's not in this video, but the Cramer's rule says when the denominator is not 0, when the denominator is not 0. And in the next video, in the final video, we're going to talk about what happens when that denominator is 0. I am missing something here. What I'm missing is the thing where I get to stop recording. Oh, it's hiding. Found it.